we can do pretty much anything we want that's possible to do. So here's if you like, an application that illustrates how integration by parts can be helpful. And we're going to find the volume of an exponential wine glass here. Again, don't try this at home. So let's see. It's going to be this beautiful guy here, I think. Okay, so what's it going to be? This graph is going to be y is equal to e to the x. There, and we're going to rotate it around the y-axis. And this level here is the height y equals 1, and the top, let's say, is y is equal to e, so that the horizontal here coming down is x equals 1. Okay? Now, there are two ways to set up this problem. And so there are two methods. And this is also a good review because, of course, we did this in the last unit. The two methods are horizontal and vertical slices. Those are the two ways we can do this. Now, if we do it with, so let's start out with the horizontal ones. That's this shape here, and we're going like that. And the horizontal slices mean that this little bit here is a thickness dy. And then we're going to wrap that around, so this is going to become a disk. This is the method of disks. And what's this distance here? Well, this place is x, and so the disk has area pi x squared, and we're going to add up the thickness of the disks, and we're going to integrate from 1 to e. So here's our volume. And now we have one last little item of business before we can evaluate this integral, and that is that we need to know the relationship here on this curve that y is e to the x. So that means x is natural log of y. And in order to evaluate this integral, we have to evaluate x correctly as a function of y. So that's the integral from 1 to e of log y, the quantity squared, times pi dy. So now you see that this is an integral that we did calculate already. And in fact, it's sitting right here, except with the variable x instead of the variable y. So the answer, which we already had, is this f2 of y here. So maybe I'll write it that way. So this is f2 of y between 1 and e. And now let's figure out what it is. It's written over there. It's y log y squared minus 2y log y minus y. The whole thing evaluated at 1e. All right. And that is, if I plug in e here, I get e. Right? Oh, except there's a factor of pi there, sorry. I missed the pi factor. So there's an e here, and then I subtract off, well, at 1 this is e minus e, so it cancels. There's nothing left. And then at 1 I get log 1 is 0, log 1 is 0. There's only one term left, which is 2. So it's minus 2. That's the answer. All right, now we get to compare that with what happens if we do it the other way. So what's the vertical? Vertical. So by vertical slicing, we get shells. And that starts, that's in the x variable. It starts at 0 and ends at 1, and it's dx. And what are the shells? Well, the shells are, if I can draw the picture again, they start, the top value is E, and the bottom value is I need a little bit of room for this. The bottom value is y, and then we have 2 pi x is the circumference as we sweep it around, dx. All right, so here's our new volume expressed in this different way. So now I'm going to plug in what this is. It's the integral from 0 to 1 of e minus e to the x. That's the formula for y, 2 pi x dx. And what you see is that you get the integral from 0 to 1 of 2 pi ex dx. That's easy, right? That's just 2 pi e times a half, right? This one is just the area of a triangle if I factor out the 2 pi e. And then the other piece is the integral of 2 pi x e to the x dx from 0 to 1. Are you asking me whether I need an x squared here? I just evaluated the integral. I just did it geometrically. I said this is the area of a triangle. I didn't anti-differentiate and evaluate it. I just told you the number because it's a definite integral. Now. All right? So now this one here I can read off from right up here above it. This is G1, right? So this is equal to, let's check it out here. So this is pi e, right, minus 2 pi times G1 of x evaluated at 0 and 1. So let's make sure that it's the same as what we had before. It's pi e minus 2 pi times, here's G1, so it's x e to the x minus e to the x. So at x equals 1, that cancels. But at the bottom end, it's e to the 0, so it's minus 1 here. All right? Is that right? Yep. So it's pi e minus 2. It's the same. Yeah, question. From here to here, is that the question?
Yeah, wouldn't that be e to the 1 minus x times x?
The step here is just the distributive law. This is e times 2 pi times x. That's this term. And the other term, the minus sign is outside. The 2 pi I factored out. And the x and the e to the x stayed inside the integral sign.